Hey friends, welcome back to the channel. And in the previous video, we had a kind of introductory session when we are talking about the single server setup, and we talk about how the client send the request to the DNS, which in returns sends the IP address, and using that IP address, web servers send the HTML page, maybe in form of JSON for web servers and HTTP protocol for mobile apps. Now in this video, we are going to analyze this setup when we are dealing with multiple users, when we have significant amount of people using our services. So for that case, we need to have two different web tier. First is the web server to handle the traffic from mobile apps or the web servers, and second is the database. Now we are separating these two things in different parts so that we can scale them independently. So what is now going to happen is the web server is going to send the request for read, write, update of any data to a database, and a database will return the updated data whenever the web server request that. Now, talking about the database specifically, we'll be having a kind of general discussion, and we'll go deep into different kind of database in the upcoming videos. So mostly we can classify databases into two parts, which are relational databases and non-relational databases. So relational databases are your SQL databases, which we also call as relational databases. So a common examples for these kind of databases are MySQL, Oracle databases, and PostgreSQL. Now the thing is, what we do in relational databases is we represent and store data in tables and forms. Also, we can use kind of join operations using SQL across these multiple database table that we created. Second type of databases are the non-relational databases, and common examples for that would be CouchDB, Cassandra, Amazon DynamoDB, and we have four different kind of categories for these non-relational databases, because they are not like the relational databases in which we have tables and rows, and in which we can have join operations. So these don't have join operations, and the different categories are the key value stores, graph stores, only column stores, and only document stores. Now coming to which one to use is actually more dependent on what are your requirements when you are developing your system. For most of the developers, it will be beneficial if they use the relational databases, because these are in the market for last 30-40 years, and these are working perfectly well. So most of the developers will do pretty good if they go on with the relational databases. Now coming to when to use non-relational databases, we have different factors that you can consider. So first is low latency. So if your application needs super low latency, you can go with the non-relational databases, or your data is unstructured. So unlike relational databases where you need to have some kind of common keys between different kind of databases, so that you can have kind of join operations between multiple databases. If you don't have that, you can use these, or you need to serialize and deserialize data. For example, JSON format is a very common example for that. If you're using that, non-relational databases would be pretty good use case for you. And last is you need to store massive amount of data. So for all these kind of use cases, if your application requires any of these or most of these, you can go ahead with the non-relational databases. Now coming to our web server. Now when we are talking about the scaling of our web servers, because there can be thousands and hundreds of thousands, millions of people that could use our application, and the traffic would be enormous when we are talking about that kind of people using our services. So we need to scale our web servers. Now there are commonly two ways, which are horizontal scaling and other is vertical scaling. We can have a pretty good example when we are talking about the scaling of our web servers. Now, so consider you are opening up a restaurant and you have a chef working for you full time, and you have certain customers, let's say 5 per day. So now you are serving your customers good, everyone is happy, but let's say your restaurant is in huge demand and lots of people are coming to your restaurants now. Now, if we talk about a particular chef, he has limited time and he can only make a limited number of dishes. For that case, we can ask him to work overtime, maybe 10-12 hours a day, but there's going to be a cap for that. So that is the vertical scaling for our web servers. That means we are expanding our already systems, or in a particular system we are just increasing the resources in a single system. Other thing you can do is, coming back to our restaurant example, rather than having just one chef, we can have multiple chefs and all of them can work together and fulfill the requirements, and each can work independently, and we can scale each chef independently. So each chef can work, let's say 10-12 hours a day, and we can do it for multiple chefs. And how many chefs we can have? In theory we can have infinite chefs. So same we can do is in kind of our web servers. So we can have infinite servers and we can scale all our servers independently. So this is known as the horizontal scaling. Now let's say we have multiple servers. Just for example, I have said like S1 to S4, and for vertical scaling we have a huge server in which we have increased the resources as much as we could. Now, discussing about the trade-offs. So whenever we have multiple requests to our web servers, we need a load balancer. So consider the traffic is coming to our web servers. We need to have a kind of load balancer that would direct the traffic to which server to get through. And coming back to our vertical scaling, that the huge server that we have, we don't need a load balancer because all the requests will be coming down directly to this huge server. Second is the data inconsistency. We need to have a communication between all these servers, and if there is any network failure between any of these servers, we would have stale data. So let's say this S4 servers goes offline, we will be having stale data in the S4, and if there is any request coming from the client to S4, it will return the stale data. So this is the data inconsistency that we can observe. But in case of our vertical scaling, we won't observe this thing because all the queries will be coming to our only server and we won't have stale data in that. Third is, we need to have network calls for communication. So we have multiple servers, but we need to have some kind of communication between all these servers to keep our data consistent across all. So for that, we need to have network calls to have the communication between these servers. And in our vertical scaling case, we only need the internal communication. We don't need any network calls. Coming to the resilient feature, horizontal scaling is resilient. So there can be techniques when one of the server goes offline. There are other servers to take care of the traffic that has been there at that time. But in case of vertical scaling, there is a single point of failure. So we have only one server, and if it goes offline, our application goes offline. And in the end, there's just one thing, which is the horizontal scaling. In theory, we can scale it well. We can scale it to infinite. We can have n number of servers that can handle all the traffics. In the case of vertical scaling, there is a hardware limit. We have limited resources that we can give to a single server. This is on the upper level. What are the differences between the horizontal scaling and vertical scaling of the web servers? And this was the first part of how we can accommodate huge traffic that is coming to our applications. Now, in the next video, we'll be talking about how the load balancer would work, because in In practical, horizontal scaling would be always preferred as compared to the vertical scaling because of these multiple points, which is single point of failure, hardware limit. In practical use, we will always be using horizontal scaling and will be using a load balancer. So here the load balancer will be coming, and we need to direct the traffic that is coming from our clients to these multiple servers. So all this discussion we'll be having in our next video. So that's it for today. See you in the next one.